Okay, for my retro challenge for the Winter Warmup 2014, I am going to attempt to write a program for the Commodore 64 in a language other than BASIC. I chose to use a rather obscure language available for the Commodore 64 called PROMAL, P-R-O-M-A-L, and hopefully learn something about this language. PROMAL itself is more than just a programming language. It is more of a programming environment. What I have set up here is a Commodore 64 breadbox, well yellowed from age. I also have, if I don't mess up my things here, 2 disk drives. Works best with 2 disk drives. And a monitor. I'm just using a little 9-inch studio television broadcast monitor. And I have a fast load cartridge I'm going to use. I have found out in some of my preliminary tests with this PROMAL application, because it is a developer's environment that basically overrides the basic environment built into the computer. Sometimes it has issues with fast load cartridges. Sometimes it has issues without a fast load cartridge. It also has its own built-in fast load capabilities that sometimes conflicts with fast load, sometimes doesn't. I haven't found a completely consistent method of booting up the PROMAL environment, but I found that if I leave fast load in, it tends to work most of the time. Anyway, PROMAL, I'm working off of a backup disk. I don't want to ruin an original. PROMAL has everything it needs on an original disk called the Executive. That's the primary PROMAL environment disk. Think of it like GEOS, but without graphics. It's not a GUI. It's a text-based environment. So, sorry about the banding here. That's just, the NTSC incompatibilities. But I'll get started with just launching PROMAL. So fast load in, I just do /PROMAL. Whoops. Me and my fat fingers, I hit the equal key. But I guess it didn't care, because it's loading it right now. And it loads up a small basic program, and then it launches basically a machine code with this sys command. So I'll go ahead and run it. Now, a successful load of PROMAL will start with a blank screen. It shouldn't do a headbang like it just did. It says can't load it. Okay, next step. It could be the PROMAL's built-in fast load capabilities called Dyno Disk, interrupting with fast load. So in order to clear that out, you load PROMAL again without running it. And then you poke 3555, 0. That turns off Dyno Disk, and that's a portion of memory that gets loaded up, in the machine language portion. Then you can type run, or somehow I have a bad disk. Oh, there we go. First thing it does is it loads the built-in editor. That takes a little bit of time. And you'll know it's going to be a successful load if it starts loading the remaining components. The remaining components include the executive environment and the built-in function library. It should load those 3 parts in order. The editor seems to take a while. Okay, there's the executive. Let me see if I can zoom in on this a little bit more. Don't know what it will do to that banding, but you should at least be able to see the screen. Yeah, me and my cheap, no frills video capabilities here. Now it's loading the library, and then the environment's running. It says PROMAL Development System Executive, version 2.1, copyright 1986, SMA Incorporated. PROMAL is a trademark of Systems Management Associations, Inc. Please enter today's date. I haven't really found any date issues, unless I guess you're using a program or you write a program that uses dates. It seems to be Y2K friendly. Let's see, 14. Okay, now I'm in the environment. The environment boots up with a command prompt, basically. And it gives you a list of all the function key assignments, and you can change these as needed, but these are some of the more common ones, like F5. If I hit F5, it'll type up the word files, and files is kind of like a directory. So if I hit files and hit return, it will show me the contents of the files on drive 8, or what it calls disk 0 in the environment. So if I go files and then do 0:, that means I want to read the files in disk 0, which is actually drive 8, but it defaults to disk 0 if you don't specify it. Now these files that you see here, you'll see files with a .s and files with a .c. The .s files are the source codes. .c is the compiled command for PROMAL, and it only works in the PROMAL environment. So you have to be in this environment to run any of the programs with the .c. So think of it as an executable. Let's see. Okay, we'll go back with files. If I hit files and I hit 1:, that's equivalent to looking at the directory of drive 9, which I have the graphic tools library for PROMAL in there, because I'm going to need some of that stuff. I don't know if it supports a third disk drive. I'm not hooking one up, but when you program in PROMAL, you're basically programming in, like I said before, in an environment. PROMAL has kind of a, I would say, sort of a Pascal look to it. Let me show what a sample file looks like. We'll just look at the list of files here on PROMAL, and I'll find a small source code. How about real demo.s? That's a source code. Well, one of the built-in commands for PROMAL is type, so I use the type command, and I just specify the file I want to type out to the screen, and that's real demo.s. So I want to look at the source code. Now when I hit enter, it'll load up the source code and start displaying it on the screen. I can use the control key, like in BASIC, to slow down the listing, or I can hold down the run stop key and it will pause it while I'm holding it down. It has a different function here than in BASIC. So I'll hit return, and now it's showing the program layout. I'm using the control key to slow it down. If I hold down run stop, it freezes. So the program starts out, the source code starts out with the name of the program. You type program followed by the name you want to give the program. This will become your executable name. Comments are preceded with a semicolon. You include library functions. This one uses the built-in library. You have to include that if you want to use some of the basic functionality. And I'm also including the file called real funcs, F-U-N-C-S. It's real functions. It's like, this is for real numbers. Mathematically, it's for real numbers. So it's going to use precision numbers. Some of the initialization code, I have a variable called I, which is a full word length, which is, if I recall right, full word is 16-bit. Then I have a real, full floating point variable called theta, one called theta min, theta max, delta theta. You can kind of get an idea what these are for. You can specify data, like you can define, in this case, DEGRAD, which I guess means degrees and radians, equals this value. So this might be used as a conversion. So predefining a data variable as a real floating point number, degree rad, and I believe this is probably a conversion value. So if you want to convert degrees to rads, you would multiply your degrees by the degrad variable, and you should get your answer in radians. You can also do arrays, data, word, helpline. It's an array, and then it will specify, let's see, there's a semicolon there, so that is a comment, and then it looks like the array is an array of strings. Okay, so maybe I was wrong about the word. Yeah, I'm still learning this language, but this is just a quick overview. Word might be a string value, but I'll learn more about that. So this is actually using comma separated values to create an array of strings, zero indexed. And this is where it's kind of, as I said, it's kind of like Pascal. After you define all your variable templates, you would use the word begin to start your main code, and then you'll have an end to end your main code, and Pascal uses that. Plus you can have functions, so begin to end is basically like my main loop, it runs that, but then you can have callable functions that you can have elsewhere in your code. It's pretty interesting. It's like a high-level programming language, somewhat object-oriented for the Commodore 64. If you can deal with it in text-only, 40 by 25, display. So this is part of my challenge, and it's updatable through libraries. You can actually write your own libraries, or you can use existing libraries that have been released by the company or released in public domain, and you just basically add its library to your source code, and that functionality gets compiled in. Okay, so that's the end. I'll do files again here, and I'll see if I can't run one of these programs. I'm still kind of getting used to how to launch certain programs if they're on different disks and stuff. Like for example, for DOS, if you wanted to run, if you had a 2 floppy drive old DOS system, you put your DOS disk in drive A, you put your other disk in drive B, and if you wanted to run something on B, you would type B : followed by the file name that you want to run. Kind of similar here, but then you also have to make sure here that you have all your additional libraries in the appropriate location, because in most cases the sample software that it comes with expects, all the programs expect the library to be on disk 0, and if I'm trying to run something from disk 1, I have to specify it appropriately, or maybe just swap disk. But anyway, I'm just going to run a program here. Anything with a .c is a standard program within the PROMAL environment, so I'm just going to do real demo. I'm just going to type real demo. Okay, it says here this program will display a table of the trig functions sine of theta and cosine of theta over a range of theta, which I specified, at increments of delta theta, the change. So I hit Q to return to any, I hit Q and return at any prompt to exit the program. So my starting theta, let's start with 0 degrees. My ending theta will be 180. And I don't know if you hear that buzzing in the background. I got an annoying neighbor who insists on riding his 4-wheel off-road vehicle on public roadways illegally. anytime it snows around here. And it's not even his house, it's a neighbor's son. Anyway, my interval, I'll just do it every 5 degrees. And here it's demonstrating floating point calculations and trigonometric functions every 5 degrees from 0 to 180, and then this cursor means it's done. So, actually that was pretty fast. I am now going to swap disks. Oh, and that noise you hear now, that's the dog's upstairs. I'll hit files here. I just put the graphics library disk in drive 0 because there's some demos here too, like sales demo. So I'll try typing that and crossing my fingers that all the libraries are in the proper location and that it'll run. Let's see, not loaded or reloc error SGD. Oh, I know why. For the graphics library, you actually have to launch a program by issuing a command that preloads the graphic library environment, and that is, I think, boot S sales demo. Let's give this a shot. See, the thing is, for some of these programs that use third-party libraries or additional libraries, you actually have to have the library preloaded in memory in order for it to function properly. Let's see if this works, or if it's going to make a fool out of me. Unable to load sales demo, boots terminated. Okay, let's try this one. Now it's asking for WGS, which SGD and WGS are two graphics libraries on this graphics disk. This particular program requires both libraries. When I started sales demo with boot S, it only loaded the SGD library. I have to actually use boot W to load WGS and SGD. Boot W, sales demo. It took me a little while to figure this out because the documentation doesn't completely spell it out unless you read and read and read and read and read and discover the nuances to this environment. But I need to know how to do the graphic stuff, and I can't do it with the base PROMAL language. Let's see, unable to load, not enough memory, unload first. Okay, I'll get to that shortly. Let me finish what I was saying here. The base PROMAL library does not support easy graphics. I can do the equivalent of poke and peek a certain way, but I don't have any convenient graphics calls. I can't draw a line just by saying line, point A, point B. And that's what this library gives me, so I'm going to do it with this library, so I also need to understand how this works. Now, let's talk about why this said you need to unload first. I type help, gives me a list of commands that are available to me, including the function keys. One of the function keys, F6, says map. Now, here's what happens in the PROMAL environment. You have so much space. In this case, I have 33K of space, total space between 4F00 hex and CFFF. I think that's just before the kernel ROM. I have my executive environment and my editor taking up 11K of that, 11,776 bytes. I have shared variables between all the PROMAL programs taking up 256 bytes. I have a free workspace. The workspace is actually where you edit. Workspace is kind of like a RAM disk. You can put up, in this case, up to 2K in RAM disk, like source code and stuff, and you can even compile from the workspace if your program is going to be less than 2K in source code size. My active workspace is 0. I'm not using any of the workspace. My free space is only 2,300 bytes because I have object programs. Those are the PROMAL applications taking up 16K of space. And these just happen to be the programs. I have Real Demo, still loaded in memory. When you load, or when you run a program in PROMAL, it loads into memory first. And you have to unload it if you need more space. It has the boot S that I ran first. It has boot W. All this is loaded up in memory, taking up space. So I have to unload one or more of these programs. I'm just going to unload the whole thing. I'll hit unload. And now if I type map, you'll see that I'm not taking up any object space program. I now have 18K of free space to run my application. So I'll just go back to that command, that boot W command, and here's the nice thing. There's a command history built into this environment. If you hold down the control key and hit B, keep pressing it, it'll go back through your command history. And here you thought they did that first with MS-DOS. Well, I know Unix probably had it a lot, had it before this, but you thought MS-DOS was neat to have it. This environment had it. So now what it's doing, it's loading up boot W into the object memory. It's loading up that was SGD and WGS libraries into object memory, and then it's going to load the sales demo application into object memory and execute it. And there it is. It's actually drawing graphics with this graphics library. So it drew PROMAL, it drew a chart, and it's filling in the chart. Remember, this is a 1 megahertz system, so it's not going to do fills extremely fast. But it does it. I mean, it's a command environment. Now, the standard executive version of PROMAL works like GEOS, where you need to have the environment to run the program. Somebody else would have had to have bought PROMAL to run any programs that you create. But there is a developer's version of PROMAL, and I happen to have that disk too. The developer's version gives you, when you compile your program, gives you the ability to compile the needed libraries to create a standalone. Now, I haven't tested this yet, but my understanding is it creates a standalone executable disk with your program. So you basically have a standalone disk running your program. That's my goal with this when I create a game, is to make it standalone executable so I can distribute it as a D64 file to people. Oh, how to get out of this? Q for quit. So I hit Q and it cleared things up. Now if I do map again, you'll see how boot W was loaded, SGD, WGS, and sales demo, all taking up 13K of space. Now PROMAL will work with a RAM disk. With a RAM expansion. I think it's the, what is it? I forget the model number. I don't think it works with GeoRAM. I think it works with the Commodore RAM cartridge, and the problem is I don't know where mine's at, nor have I tested it. So I may find it someday, and it may or may not work. So if I find it, I'll try to put it to use. But until then, I'm programming in a very limited environment. So I'm going to unload all that, and I'm going to do files to take a look at what else is on this graph tool. Let's see, sales demo. There's a sketch program. I'm not going to run it right now because it's, it's keyboard based. It's really kludgy. Let's see, we got test shape, we got bar graph, we got function plot, we got Hanoi. I think that was a pretty neat one. Let me try running that one. Hanoi. So because it's a graphics library application, I have to do boot W, because remember I unloaded that from memory. Boot W Hanoi. I don't have to put the .c for that, but if I was going to load up the source code for something, I'd have to include the .s. Oh, and by the way, just in case you're wondering, this is a Texas Instruments expansion box, and that's a Texas Instruments cartridge, so it just happens to be here. There we go, full color graphics. This is playing out the Tower of Hanoi game, trying to move the entire staircased tower one move at a time where it can only put a smaller item on top of a larger item, and getting everything moved from this column to this column. It's a kind of a logic game. And it's done. So I'll hit Q to quit. No, it runs. No, there we go. I think it quit on its own actually. What else do I have here? I think wildcards are supported. I think if I do star.c, it'll show me all the files that. Okay, no, it won't. Like I said, I'm still learning some of this environment. So let's try test shape and see what it does. So I have boot W already installed, because if I do map, I can see boot W. So I don't think I need to run that anymore. I can just probably type test shape. Was that what it was? Test shape. Okay, there it is. See, now it's running it because I had those items on, and it just created a shape, a plane that was flying across an airplane. Files again. Let's find another graphic program I can run. Let's see, ran sales demo. Let's just do the plain bar graph one, see what that does. So I'll just type bar graph. Once again, boot W and all those libraries are already loaded into object memory. And there's a sales chart bar graph in basically 2-color. So you can see what I have to work with. It's not too difficult an environment once you get used to it. And it took me a little time before starting this retro challenge to get an idea of what this is all about, because I was giving myself a choice between PROMAL or I have a, hang on a second. I have a SuperForth 64 package, you know, complete with instructions and stuff. A great little package, but Forth works in mysterious ways, and you have to be able to basically operate your program by stacking every aspect of it. Every step of the way it has to be stacked on, you know, put onto a stack so it can be processed by the next instruction. And I just, that's a paradigm I'm not familiar with. I'd like to learn it sometime, but I'm not familiar with it. Anyway, hit Q to get out of that program. And just a quick example here. Let's say I wanted to edit one of these source codes. So I can just type edit and followed by the file name with .s, the source code. So if I do edit, I want to do function plot, funcplot.s. That will load the function plot source code. Oh, you know what? Because I unloaded everything, I also unloaded the editor. So if I do, let's do map space I have left. I could probably unload bar graph. Now if I do map again, you'll see bar graph is gone. I believe the command is get and then the name of the program. So if I want to put the editor back into the object memory, if I do get edit with my disk in 0, see now it's loading editor. So sometimes it's good to check your memory map and only unload the programs you need, so you don't have to go back and load this stuff again. Because editor was loaded when I first booted PROMAL, but when I did the unload command, I basically unloaded everything it loaded. Okay, so if I do map right now, you'll see, where is it? Oh, okay, maybe it's just maybe it goes into a mysterious space, but anyway, let's see if my theory is true. Let's see if I understood this as completely as I should. I'm putting the graphics disk back in 0 because that's my working disk right now. And I go, see, Control B to edit function plot. So, yeah, the editor must go into some special memory then. So it's loading the function plot.s file, and it takes me into a text editor where I can, freely move up and down and look and or modify the source code. So it's pretty neat stuff. This gives you an idea of what the source code looks like. These back arrows, of course, is the key to the left of the 1 on a Commodore keyboard, but the back arrow represents an underscore character because PROMAL was also made available for the Apple II. The Apple II had an underscore character, but the Commodore 64 doesn't traditionally have an underscore character. They have an underscore graphic, but it doesn't match with the the ASCII table, standard ASCII table. So, and again, neither does a back arrow, but that's what it is. So, and crossing PROMAL code between an Apple II version of PROMAL and Commodore 64 PROMAL, wherever you see an underscore on one, you'll put a back arrow on this. Doesn't mean an arrow or anything. It's just a placeholder character that represents like an underscore. You would actually read this W underscore tick underscore DX. Now let's just say I made my edits and stuff here. I have to hit F8 to quit, Shift F8, and then it asks me, this is the buffer size I have to work with, this is the file name I'm working with, this is the file size I'm working with. Do I want to quit the editor and not save my work? Do I want to replace the original file, which means it will write my changes out to the same file name that I've used? Do I want to write to a new file? That's what I'm going to do here. I'm going to put now that I have this in memory, I'm going to put my boot disk back in, my original boot working disk. I'm going to write this to a new file. I'll hit N, enter new file name. It'll assume drive 0 unless I specify it otherwise. Oh, what the heck, I'll specify it just to show you how it works. And I'll call this fplot.s. Now it's writing fplot to my boot disk. And then I can hit Q to quit. Now if I do files, you'll see here that on my boot disk I have fplot.s. Let's compile this into an application. Compile fplot.s. This may or may not work. I still have the libraries in memory. And I think because this uses those graphic libraries, I think the graphic libraries have to be in memory to work, or it has to have direct access to the source code for those libraries. This may or may not work, as I said. Still a few things I'm tweaking. I still need to be absolutely sure where I need to put all my files, and wherever I have them, I can at least work with them when it comes to writing the applications and compiling. Okay, now it's starting the compiler process. It was actually loading the compiler. Now, okay, so it's including the basic library, the PROMAL standard library. It's reading all the lines. Okay, there was an error. It'll most likely give me an error code and a description soon. Cannot open include file sgd.e. Okay, I need the sge.e file, which is, let me do a files here. Files, drive 1. Okay, you see here sgd.c, sgd.e, and there's also an sgd.s, I believe. Well, the .e files, my understanding, are basically like relocatable libraries, whereas the .c file is actually a compiled program, PROMAL program. So it's needing the .e because that's the file that you include in your source code if you want to use these graphic libraries. And I'll have to probably copy the wgs.e. So let's see, sgd and wgs. So I might as well do this now because I'm going to need it. I can go copy 1:sgd.e to drive 0, and it'll copy that library executable, or that maybe the .e stands for environmental. Okay, so it's sgd, and I'll do copy 1:wgs.e to drive 0, because I'm going to want these on the single disk I'm working with, especially if I'm going to use them. I don't have to keep switching disks or referencing another drive in my source code, because I think I could modify the source code to put 1:sgd.e wherever the line imports it. Okay, so I have these two now. Let's try compiling it again. So Control B, go all the way back to compile fplot.s. The compiler ran quicker this time because the compiler is now in memory. Now there's a chance I'll run out of memory while it's compiling, so which means I'll have to go and unload a few programs. Okay, so it found the .sgd.e, so it's including that in the compile process. Think of it as like statically linking a library, for those who are familiar with programming in the C environment. Okay, I have another error. This might be a memory error. Symbol table overflow, use B option. Okay. Because I'm working with limited memory, I can do compile, the name of the file, and if I type B, it will introduce an option to the compiler to ask me if I want to unload programs if needed. The B option basically clears extra buffers, or extra buffer space. Oh, I'm getting another error now. What? Yeah. Okay, this is really weird. Bear with me on this a second. Let's take a look at my memory map. I have boot W and compile. I'm going to try something real quick, and this is only because I've done it before and I don't quite know the explanation. But if I do B equals, and was it 011C, you can give it some sort of hex number which defines a certain number of buffers. And I just remember seeing this in the original documentation. I can't explain why it is what it is. So replace existing fplot.c, yes. Reading line 1 error. Now what? Symbol table overflow. Okay, I'm going to do this. I'm going to unload boot W because I know that's in memory. And I'm going to go back to running this with just the plain B option. This isn't a very big file. I've actually test compiled other demo programs that came with this without any problems, so I don't know what's going on here. Oh, you know what? It's loading compile again because when I used the B option before, it unloaded everything in memory. I'm beginning to think that the fast load cartridge really isn't in operation right now. Okay, we'll keep going here. We'll see what happens. It looks like it's going to work now, but oh, there we go. Error 135. Now, was it missing? See, it's not giving me any errors now. I wonder if my environment's corrupt, which kind of would make sense because this is a limited memory environment, and who knows how easy it would be to mess up, pointers to RAM or, whatever the case may be. So what I'm going to do is end this introduction video here. You will see me compile stuff later as I work on my application. I was hoping this would work, but you saw what PROMAL can do, and you kind of saw how the environment works. And I'll learn more, and subsequently you'll learn more about the environment yourself. Anyway, that's it for now, and next video is most likely going to be when I'm starting my program or getting some of the core functionality created. So we'll talk to you then.